Good day and welcome to Vision TV. In this today's video, we want to expose the method or the secret on how to determine the endpoint of a titration by theoretical method or by calculation method. We all are aware that whatever that is going to be done practically first should be understood theoretically. So tomorrow is going to be practical chemistry examination for NECO. So if you don't have the apparatus, the laboratory apparatus that is needed for the practical, the sole reason why practical is being done is for you to determine your endpoint. So I shall be showing you how to determine the endpoint of tomorrow's exam theoretically. So come with me as we go into this video. This year 2026 NECO practical chemistry sample, the endpoint. I want to first of all, let me draw a line here. This year NECO has sent us that we should prepare the following reagents. For our solution A, which is usually written as AN, we're given 2.7 Cn cube of H2SO4, tetrazosulfate acid. Alright, for the B, solution B, which is represented as Bn, we're given 4.0 gram of, let's say 4.0 gram per Dn cube of sodium hydroxide. Okay, this again 2.7 Cn cube of H2SO4 per Dn cube. This is going to be dissolved in 1 Dn cube per Dn cube. These are the samples for the equation number 1 tomorrow exam. These are the samples, or these are the information Waye gave us. Now, the sole reason of making this video is how do we determine the endpoint? Assuming you don't have the apparatus to conduct the practical in there, I'm going to show you the secret on how to determine the endpoint. Alright? So let us see, if you want to determine the endpoint of tomorrow's practical, it is very, very simple. We are going to start from the acid, which is H2SO4 tetrazosulfate acid. We know that we are going to use a formula, let me say solution. We are first going to determine the concentration of the acid in mole per Dn cube, and then we'll determine the molarity or the concentration of the base in mole per Dn cube. Then we use that to find the volume of acid that is going to be required, which of course we call endpoint. Okay, come with me. We are going to apply the formula C1 V1 is equal to C2 V2. This formula is called dilution formula or dilution law. Alright, from our parameters given, the concentration of the acid is the stock concentration, and of course, anytime you get stock tetrazosulfate acid, the concentration from the industry is usually given as 18 mole per Dn cube. Alright? Then the V1 here become the volume that was required to dissolve in 1 Dn cube, okay, which is 2.7 Cn cube. Alright? So C2 here is a final concentration. If we have dissolved this volume of the acids, if we have dissolved this volume of the acid in 1 Dn cube, what is going to be the final concentration? We say we don't know. So C2 here is the final concentration, while our V2 here is going to be our final volume. The final volume is usually going to be 1000 centimeter cube. 1000 centimeter cube is the same thing as 1 Dn cube, because the question says it's usually going to say per Dn cube. Anytime you hear the word per Dn cube, that means it's going to be dissolved in 1000 centimeter cube. Alright, so let us find the concentration of this acid. If 2.7 Cn cube of the acid is dissolved in 1000 Cn cube, which is the same thing as 1 Dn cube. Okay, so we make C2 the subject of formula. If we make C2, it's like saying C1 V1 is equal to C2 V2. Alright, so we are looking for our C2, so we divide all through by V2. So that this V2 cancels this V2. So our C2 is going to be C1 V1 all over V2, V2. Alright, so this simply means that if we want to find the concentration of the acid when we have dissolved 2.7 Cn cube of the acid in 1 Dn cube, so we are going to multiply the concentration, the initial concentration of the acid, that is the stock acid, the initial volume, That is the volume to which we are asked to dissolve in 1 DN cube, and then divide by the final volume. Of course, in this case, the final volume is going to be 1000 CN cube. Okay, let me come this way. So our C2 is going to be equal to, our C1 is 18 mole per DN cube. Our V1 is going to be the volume that was given by NECO. And then all of V2. V2 is 1000 CN cube. So let us see. My calculation. 18 times 2. And then all of 1000. Okay, the answer is going to give us 0.0486 mole per DN. Let me put it this way. I'm going to have 0.0486 mole per DN. So this is going to be the final concentration of the acid when 2.7 grams, 2.7 CN cube of the acid is dissolved in 1000 CN cube. Alright, so that is this one now is going to form our CA. This one now is going to form our CA. That is our concentration of the acid in mole per DN. That simply means that our concentration of the acid in mole per DN is going to 0.0486 mole per DN. So we have gotten our CA here. Now, in order for us to be able to predict the volume of the acid that is going to be used, let us find the concentration, molar concentration of the base from the sample or from the information given to us. Let us find the molar concentration of the base. Okay, so permit me, let me erase this. Let me continue from here first. So we are given for the base is the base Bn is sodium hydroxide. Let me see. Alright, we are giving sodium hydroxide. And of course, the mass given was 4.0 gram per DN cube. Alright, how do we determine the molar concentration of this? First, we should look at the molar mass of sodium hydroxide. The molar mass of sodium hydroxide is going to be 23, because the atomic mass of sodium is 23, plus that of oxygen, which is 16, plus that of hydrogen is going to be this. Total, we are going to have 40 grams per mole. So how do we find concentration in mole per DN cube? Come in mole per DN cube of B is going to be mass in gram per DN cube all over molar mass. So okay, we can now erase this since our body is not big enough. Let us erase this. We want to find the concentration of the base so that we will be able to deduce our volume of acid that is used. Okay, so to find the concentration of B, we say com of B is going to be mass. Mass given, we're given 4.0 gram per DN cube. The molar mass calculated is calculated to be 40 gram per mole. So by the time we divide 4.0 gram by 40, we are going to obtain concentration of 0.1 mole per DN cube. 0.1 mole per DN. So that simply means that our molar concentration of the base is going to be 0.1 mole per DN. Now, it is from here that we now use to determine the endpoint, the volume of the acid that is going to be used during the practical. Mind you, whether or not you do the practical or not, you shall are going to, by using the theoretical method, whether you do the practical or not, it is still going to match with the theoretically calculated volume. Alright, so we can now apply our mole ratio formula. But before we apply our mole ratio formula, we are going to write the equation of reaction involve between sodium hydroxide and tetrahydroxide surfaces. So the equation is like this. Let us put down the equation. The equation is H2SO4 combined with sodium hydroxide to form sodium tetrahydrosurfaces and H2. So for us to balance this, we put this together. Alright, so we can now apply our mole ratio formula that says Ca Va all over Cb Vb is equal to Na all over Nb. Alright, so in this case here, our Ca was calculated to be, alright, so our Ca, which is the molar concentration of the acid, we have determined it to be 0.0486 mole per dl cube. Alright, our Va, we don't know. That is our endpoint that we are aiming at calculating. We don't know. Okay, our Cb is equal to 0.1 mole per dl cube. Cb is the molar concentration of the base, which we just calculated to be 0.1 mole per dl cube. Alright, our Vb is usually going to be given. Vb is usually going to be given from, you are going to get Vb from your pipettes. For several schools, so many schools, they have different sizes of pipette, but the commonest size of pipette that is used by so many schools is going to be that of 25 cm. So our Vb in this case, if your school is using that of 20, then here will be 20. But if your school is using that of 25 cm, then here is going to be 25 cm. Alright, the next thing is our Na. Na simply means number of moles of acid, and then also our Nb. Nb is the number of moles of the base. And how do we get that one? That is gotten from the equation of reaction as it is balanced. So our Na here, that's the number of moles of acid here is 1, and the number of moles of base is 2. So our Na is 1 and our Nb is 2. So let us see how we can now find the endpoint, that is the V, the volume of acid that is used. Okay? So if we make Va, if we make V a subject of formula, that is where we are going to get our endpoint. So from here, let us make Va. Remember, we know everything here apart from Va. And by the time we are able to calculate the value of Va, that means we have gotten our endpoint. So our Va is going to be Cb, Vb, Na all over Ca, Nb. Alright? So Va is going to be Cb, Vb, Na all over Ca and Nb. Alright, which is our Cb is given to be 0.1 mole per dl cube. Our Vb, we say is 25 cm, depending on the size of your school pipette, it's going to be 25 cm cube. Alright? Our Na, number of moles of the acid is given to be 1. All of our Cb is going to be Ca, our Ca is 0.0486. Alright? And our Nb is 2. So let us now evaluate this. Whatever volume we have is going to be the endpoint to our practical. Okay, let us evaluate 0.1 times 25 divided by 0.0486 multiplied by 2. Alright, it is going to give us a volume of 25.72 cm. 25. So this can also be written as 25.70 cm. So this is our endpoint. So the practical chemistry that will be done tomorrow, whether or not you have the apparatus to conduct the practical in the lab tomorrow, by the time you are able to find the endpoint or the volume of acid used, every other thing for question number 1 is covered. Because the sole reason or the sole aim of you doing practical in the lab is for you to ensure that you get your VA. So for our tomorrow exam, our VA or our endpoint shall be 25.7. Mind you, because of what is called environmental factors, whenever you are performing the practical, the VA will vary. There are situations where some students will do the practical, they may end up getting the endpoint to either be only 25.00 CMQ or even 24.9 or even 24.5. Let's say 24.7. All of these are still going to fall within the range due to some environmental factors. So this is how we can determine the endpoint of our practical chemistry tomorrow for the next week. Thank you very much. I shall be unveiling the sample question as pertaining to what is going to be expression for question number 1 for the practical exam tomorrow. Thank you very much. Bye.